Good morning students. Today we are going to see about the breakdown in PN junction diode. What are the breakdowns are in PN junction diode? So first one, there are two types of breakdown. One is avalanche breakdown and another one is Zener breakdown. What is avalanche breakdown and what is Zener breakdown? First, avalanche breakdown. So in the avalanche breakdown that occurs in the PN junction diode, that is when moderately doped and has a thick junction, means that depletion layer is width and it's high. Okay, it occurs in that layer. So that avalanche breakdown that usually occurs means we apply a high reverse voltage across the diode, means so higher than the Zener breakdown voltage. So we increase the applied reverse voltage, the electric field across the junction that will keep increasing in the avalanche breakdown. Is if we apply the reverse voltage and the depletion layer with, then the generator electric field can be calculated as with the formula of EA is equal to VA by D. So the generated electric field that exert a force on electrons at the junction that frees the covalent bond. Okay, the free electron will gain an acceleration that start moving across the junction with high velocity. So this type will occurs in the collision with neighboring atoms. So the collision with high velocity that generate with free electrons. So the electron will start a drifting and electron hole pair recombination. So it has the net current rapidly that increases. So from this, the avalanche breakdown that occurs at the voltage that is higher than the Zener breakdown voltage. So what is the reason behind this? Means it's very simple. So the avalanche breakdown that occurs in the diode that is moderately doped and the junction width is high. When compared to the Zener breakdown that occurs in the diode with heavily doped and the junction is small. So the electric field that occurred due to the reverse voltage in Zener breakdown, the calculated is E is equal to V by D. So in Zener breakdown, the electric field to break the electrons from covalent band at with lesser voltage, okay, than in avalanche breakdown. So what's the reason behind this? Means the reason that's because of the thin depletion layer. So in avalanche breakdown, the thin layer, the depletion layer is higher. So more reverse voltage is applied to develop this electric field. But in but in Zener diode, it's enough to break the electrons free. Okay. So here the Zener breakdown occurs at the heavily doped narrow depletion layer. The avalanche breakdown occurs at the lightly doped depletion layer. In Zener breakdown, it sets a very strong electric field across the narrow layer. In avalanche breakdown, electric field is not that much of strong to produce the Zener breakdown. Okay, in Zener breakdown, the electric field is strong. Okay. So it increases the reverse voltage that producing large number of current carriers. But in avalanche breakdown, the minority carriers that is collide with the depletion region, means the generator carriers is accelerated by the electric field that results in more collision and generates the avalanche of current carriers. Okay. In Zener breakdown, it exhibits negative temperature coefficient, that is breakdown voltage decreases with temperature that increases. In avalanche breakdown, positive temperature coefficient, that is the breakdown voltage increases means it increases in temperature. So what are the basis of avalanche and Zener breakdown? First, the process. What is the process we are doing in avalanche breakdown? Means high value of reverse bias impact ionization. In Zener breakdown, quantum tunneling and for a specific voltage. What's the structure in of avalanche breakdown? Means PN junction diode with normal doping. In Zener diode, highly doping in PNN region. Okay, what next? The temperature coefficient in avalanche breakdown, it is positive temperature coefficient. In Zener breakdown, the temperature coefficient is negative. This is the graphical representation of avalanche breakdown and Zener breakdown. This is the picture of Zener diode. This is another example for avalanche diode.